to showcase an example of scripting using one of the files that we worked on previously. This is a file, a skull with a hole in it. It's a demo file from Materialise. And we segmented out the maxilla, mandible, a couple of cervical spine, vertebral bodies, and the script that we're going to run is an example of reducing the polygon count of these files to make them an asset for augmented reality or virtual reality applications. So for these types of applications, if you have 3D files with a very large number of polygons, it can reduce the performance while you're wearing a headset or something like that. So we would like to do this, very quickly and for a large number of 3D files to have essentially a limiter that would reduce the total number of triangles under a threshold. So if you want to see how many triangles are in any model, you can just click on it, and underneath these properties, you can see the number of triangles right here. And what our script will do is look at the visible parts that are active, and you have a setting of how many triangles you want to keep as a maximum, and it will loop through a reduce function, which is typically under this fix menu. The reduce number of triangles with a certain amount of geometrical error that's allowed. So the loop part of the script will start at a certain error value and count the number of triangles. And then if the number of triangles is not less than the threshold that you've set, it will increase the error allowed by a little bit and reduce again. And that iteratively will decrease the total triangle count for either a certain number of cycles or until your limit is hit. So let's run it right here, see what happens. So it says basically a pop-up message says the parts will be reduced to under 100,000 triangles, and we will run a auto fix wizard on it to prep the file for AR VR. You can click cancel to avoid it, or just hide or just show the parts that you want to use, and then click OK. So click OK, see it's working. Okay, and here we see that the number of triangles, this total number of triangles at the end is 90,000. And we've gone through 2 loops, and the allowed error is 0.15 millimeters. You see it's also created a new folder here that will contain the parts that were visible, and it will add the suffix _ARVR. We can hide this for a second, and if we click over here, we can show the triangles of the native part. And then if we show only this folder, see how those triangles change for the reduced part. So actually it doesn't look a lot different, but the number of triangles is significantly less. So if we highlight these 2 parts, we can see that the number of triangles before was 180,000. And if we click on this folder, we see that these are 90,000. So let's look at the script and see how that happened. All right, so for this script, the first thing we start with is a date that we created this, and maybe contributors or authors of the script. We say what version of software we used that we validated the script in. We have a little commented out section that says what the purpose of the script is. Maybe we would have inputs and outputs. And then we have import any libraries that we need. So for any 3-matic scripts, we need to import Trimatic. We could set a view. We can put the maximum number of triangles. So we set whatever limit we want. And then we have the message box that pops up and gives a message to the user and says what that variable was. We use the plus sign and convert the variable to a string to let that happen. Then we get a list of all the parts, and we use this for loop to do some kind of function as we go through each part in that list. And basically this says as we go through the parts, if that part is visible, then we want to duplicate it. What that does in 3Matic is puts that, like duplicates the part, puts it at the bottom of the part list, and retitles it as the original part name underscore duplicate. So this next line basically grabs that part, assigns it to variable A, and renames it by replacing the underscore duplicate with underscore ARVR. Then we make a new list where we find all the parts with ARVR in it, and we're doing find parts here. This is allowing us to use regular expression where this dot asterisk is a wild card, so it could be anything. So that's basically all the parts that we duplicated will be in this list. And then for let's get rid of this part. For all of those, basically we have to think about, what if it doesn't come with any parts? So this is called an edge case. This means if no parts were visible, then the length of this ARVR parts list would be 0, and we can just tell the user that no parts were visible. And we could rerun the script, or we could actually make this the like part of the loop up here where we could just have the user show parts, click OK, and then we'll run the rest of the script. Here we set total number of triangles to 0, and that's just setting a variable equal to some starting point to allow us to use that later. So this is counting total number of triangles for all of those parts that were visible. We're getting total number of triangles. So for each of the parts, it's getting number of triangles in that part and adding it to the current total number of triangles. So it's just basically a cumulative sum of all the triangles in each of those parts. And then after each one, it prints how many triangles in each part. And then after it kicks out of this loop, gives you the total number in all of the parts. Here we're setting the amount of allowed error during the reduce function and setting the loop number to 0. And so this loop basically says for a loop, it'll run for either 5 loops, or it will run for if the threshold of triangles is the total number of triangles becomes less than the max, the triangle limit that we've set. So during this loop, it will do a reduce function using that error that we've provided. It will set the total number of triangles to 0, and then it will count up how many triangles exist after the reduce function. It'll increment the loop and increase our allowed error by 50 microns. So it'll keep doing that and reducing the number of triangles by increasing the amount of allowed error. After all that happens, or either of those criteria become false, then it will create a group called ARVR and put all of our reduced parts in it. So that's the function of setting a threshold of number of triangles and quickly letting our 3D models become ARVR compatible. All right, thanks for watching.